Flapping router, and route summarization. Flapping is a problem condition that can occur with dynamic routers on large internetworks. When a router is flapping, it broadcasts routing table updates that alternate between two different routes to a host. For example, the flapping router might indicate, during the first broadcast, that route A is the best route to a given host, indicate during the second broadcast, that route B is the best route, indicate during the following broadcast, that route A is best, and so on. Flapping routers thus generate unnecessary routing traffic over the network. This generally happens when a router is unnecessarily configured to load balance between paths with equal hop counts. To determine whether a router is flapping, use a network packet sniffer. Route flapping occurs when a router interface alternates rapidly between the up and down states, and it can cripple a router with excessive updates and recalculations. However, the summarization configuration prevents the RTC route flapping from affecting any other routers. While the RTC may be kept busy dealing with its own route flap, RTZ, and all upstream routers are unaware of any downstream problem. Summarization effectively insulates the other routers from the problem of route flapping. Understanding route summarization. As you can see, Winnipeg, Calgary, and Edmonton each have to advertise internal networks to the main router, located in Vancouver. Without route summarization, Vancouver would have to advertise 16 networks to Seattle. You want to use route summarization to reduce the burden on this upstream router. Step 1. Summarize Winnipeg's routes. To do this, you need to look at the routes in binary to see if there are any specific bit patterns that you can use to your advantage. What you are looking for are common bits on the network side of the addresses. Because all of these networks are /24 networks, you want to see which of the first 24 bits are common to all 4 networks. You see that the first 22 bits of the 4 networks are common. Therefore, you can summarize the 4 routes by using a subnet mask that reflects that the first 22 bits are common. This is a /22 mask, or 255. 255, 252, 0. You are left with the summarized address of 172, 16, 64, 0/22. This address, when sent to the upstream Vancouver router, will tell Vancouver. If you have any packets that are addressed to networks that have the first 22 bits in the pattern of 101.000.000.01000xx.xxxxxxxx, then send them to me here in Winnipeg. By sending one route to Vancouver, with this supernetted subnet mask, you have advertised 4 routes in one line, instead of using 4 lines. Much more efficient. Step 2. Summarize Calgary's routes. For Calgary, you do the same thing that you did for Winnipeg, look for common bit patterns in the routes. Once again, the first 22 bits are common. The summarized route is, therefore, 172.16.68.0/22. Step 3. Summarize Edmonton's routes. For Edmonton, you do the same thing that you did for Winnipeg and Calgary, look for common bit patterns in the routes. For Edmonton, the first 21 bits are common. The summarized route is, therefore, 172.16.72.0/21. The following image shows what the network looks like, with Winnipeg, Calgary, and Edmonton sending their summarized routes to Vancouver. Step 4. Summarize Vancouver's routes. Yes, you can summarize Vancouver's routes to Seattle. You continue in the same format as before. Take the routes that Winnipeg, Calgary, and Edmonton sent to Vancouver, and look for common bit patterns. Because there are 20 bits that are common, you can create one summary route, for Vancouver to send to Seattle. 172.16.64.0/20. Vancouver has now told Seattle that, in one line of a routing update, 16 different networks are being advertised. This is much more efficient than sending 16 lines in a routing update to be processed. The following image shows what the routing updates would look like, with route summarization taking place. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.